Alrighty. You know, I just noticed I don't see a note with this. I'll have to go check the text messages. But anyway, we got ourselves a Messenger M1200. Really cool little lamp. I used to own one for a little while. You can see this right here has been bent a little bit. We'll try to straighten that out. See the knob, I'm just looking at the physical things. The knob right there is broke off. Back here, the switch for the fan, the actual female part of the switch just doesn't, you don't, I'm not feeling a snap. I'll check that. I may have to replace that. And then this switch, I guess, is a fan switch. This thing flips so easy. So easy. It's usually a sign of when a switch is about to go out. I don't know. We'll see. I may. And I always hate to see electrical tape. Does anybody agree with that? You see how it uses sticky residue and all that? I'm going to probably try just do a real quick fix for this. Put some heat shrink over this. I know sometimes when you need to hurry up and fix something, you're on the fly or you got some electrical tape, but this could have been done real tight and would look a lot better. But anyway, I'm gonna go ahead and take the top off. Basically, we're just doing some simple mods to this bad boy, just to make it run a little bit more efficient. We're gonna give it a lot more thickness of wire. This is a 8 transistor or a 2x8. I'll have to see when we get into it. But honestly, I just recently had a Messenger 5-pill come in here, and it had these same exact wires on there. Same exact wires. I'd feel safer with 4 more of these. 2 more of these, 4 total on each. So we'll see how I'm going to do the power distribution and all that. So let's dig in. Alright, so here's what we're looking at. I went ahead and remove the fan case. The fan cover. This is gonna have to be replaced. This isn't even threading on anymore. Look, I can just almost pull that off just with one hand here. It's not threading anymore. There you go. See, I pulled it off with just my fingers. So we're either going to just replace this with a mono like we have it, or I may put an RCA jack back there. We'll see. Also, I'll be putting feet on here because with this thing sitting flat, this heatsink is not getting any air. I'll be completely honest, I'm absolutely blown away that Messenger did not put feet on these. I guess they just thought that the customer, the user, we're going to clean this up too. You can see all the dust. You can see the dust on the fan. See, I like to clean things up for my customers. I don't like to send it back to them the same state that it was in when it got here. I try to do my best to clean stuff up. But I guess they were just expecting people to turn their amps upside down. But if that was the case, this would be upside down. You see what I'm saying? This would be upside down if they wanted this to be ran that way with the heatsink up lock right. So regardless of how you want to run it, it's best to have feet on that. So from this point on, every Messenger I get that's done this way, I'm going to be adding feet to it. So it can lift it up off the ground so that fan can get some air. He wants me to take a look at a couple of things. This Molex connector broke off one side, which this is kind of a common thing I've seen. These amps are old, you got to remember. And after a while, this plastic starts to get a little brittle when you plug it in, unplug it, plug it in, and then that'll break off. So I'm going to do my best to find these Molex, another Molex plug to keep this OEM. I'm finishing up the video, baby, and I'll be in. You just reminded me. So about the only other thing I can think of you can do, since I'm not a fabricating genius, is to try to get a square piece to cover this up, mount it, drill a circular hole, and put an 8-pin. Let's see, 1, 2, 3, 4, 5, 6 to 8-pin mic jack in there of some sort. I'm gonna go ahead and tell you, I'm not crazy about that size relay. I really am not. But it is an 8-amp relay, so we're just gonna leave it. I'm not gonna go to that craziness if I don't actually have to replacing relays. I was wrong about this switch right here. This isn't the switch for the fan. This is actually a what you call a driver delete switch. It's not what you would call staging. I mean, it technically is a type of staging, but it's really a driver delete. Up is driver on, down is driver off, and it works fairly good. I personally never rocked with this style because if you'll notice the input right here, it's got 2 pieces of coax hooked up to it. You see that? Because this right here is added later. But the reason why this does work, because this second coax does come and keeps the input tuning capacitor right here for this. This is the input tune. This gap right here is the impedance matching capacitor for this splitter network. So it's connected by this coax. Only reason I never did this personally is this driver's got power. RF travels down here through the output transformer, but since there's no input signal, you are good to go. So I may play with this more in the future and do a little delete circuit like this. I'll be completely honest with you, I never actually tried it. I always just went with a full staging unit to let the person have the option of using the driver or not. But it does work. It does work. He wants me to mic in all these tremors, get rid of them over a period of time. They can start going out on you. It's best to have some metals right there if you can fit them, if you can put them. If not, have some good, really high-end silver dip micas. And a power wire upgrade is what we'll be doing in this, which is going to be a little tricky. I'm sitting here thinking, I've already done a power wire upgrade on these before in the past. It's been a little while. I'm gonna look back and see how I did it back then. I want to say I literally just came in with 10 gauge wires and put them on the back of each transformer, just directly to the transformer. Another way too, which I've done it this way too, is I removed a whole back end right here and actually laid down a bus back here and then put chokes. I may do that. We'll see. Regardless though, these wires are coming out. This is coming out. I'm not saying this is a bad system. It isn't exactly 100% bad system. Here's the problem I've got. This is the problem I've got. Both power wires are fed right here on the very end on a piece of thin copper clad foil. You see this? This 2-pole section is getting the electrons first of a current. This one's getting them next. See, the power is flowing this direction. This is getting them third. This is getting them fourth. Now, don't you think, if you just think about this, you've got the current drop from just the surface of all this right here. Wouldn't you think this will be getting the most? This will be getting a tad bit less, possibly. This will be getting a little bit less than this one. And this one right here on the end will be suffering the most. Is that possible, y'all? I've done extensive tests, and it's 100% possible. That's why you see us laying out our power wires evenly across the bus, so that each point of connection has a closer path and a lesser path of resistance to the source to the back of the transformer, which is the load. You can pretty much say it's trying to pull the help. The transistors are pulling, but this is the path it's going, and it helps keep things cooler. This will work all day long, but will it make more heat doing this? See? Alright, well, let's see how much this is done before we do anything at all, because this amp does work. It works perfectly. It works pretty great, too, if you ask me. I'm just running this on my little 100 amp switcher over here that I always run. And luckily, it didn't turn it off. So this is a 1,000 watt slug. Go right there about 900 watts RMS. Go right there about 300. Go. Now luckily, look at this. Beautiful. The input is great. Flip it off, just hitting the 8-pill section. Not a lot. 200 watts. I honestly think it should be doing a little bit more, but you know, it is running through a lot more coax. And the input is a tad bit higher, but it's completely acceptable. Completely acceptable. All right, we'll flip it back up. A buddy of mine actually worked on this amplifier not long ago. I'm not going to say his name because he might not want that information out there. I honestly don't even know if he did a video on it or not. He may have, but he did some work on this and did a great job. He did this delete circuit. That's a nice little switch right there too. Once I took the cover off and saw which type of switch it was, then that made sense. These type of switches, they're not a higher, you don't feel that pressure as much, but these are very high dollar switches. I need to get me a few of them. I've had them a few in the past. So let's dig in. Oh, last but not least, the way this has been set up is basically for this to be stuck on high at all times, okay? That's what this wire is doing right here. All this wire is doing, there's two coaxes going to this board, one going in the board, one going out. This right here is just shorting the two center conductors. That's all that's doing. He wants the high, low, medium back in effect. I'm about to press stop. You want to say hello to the world?
Don't show my face.
I won't.
Hello, how are y'all? Ooh. Oh my God, Thomas, you have a tick on you. I swear to God.
A tick?
I swear to God, this started digging in the back of your neck.
You gotta be kidding me.
I swear on the Holy Bible.
A real tick.
I swear on the Holy Bible and Jesus himself. Well, then go get some next and we'll get him on.
Where the hell would I have picked up a tick from?
Don't touch it, because if you leave a leg in you, it will kill you. Let me get the paper towel.
As soon as you done said that, now I'm starting to feel weird on my neck. I'm glad my girl came out here, man. She said I done picked up a damn tick. I know it was when I was out there doing the grass the other day. Let me go hurry up and tell this part and get off here. All these resistors need to be replaced, at least these two. So I'm gonna remove this whole board. Also try to put it on here a little bit more straight and try to get some 5-watt resistors on here. So let me get off here while she tries to remove this supposed tick. I ain't had a tick in ages. I'm gone. I'll be back.
And you're bleeding.
Y'all, she was not lying. Look at this. That just brings chills up my dang spine.
Alright, we gotta go.
I had a freaking tick on me, man. Where the hell did that thing come from, man?
Oh no, we gotta go clean your head right there. We're doing sanitizer.
What the hell?
What?
I thought.
What?
How was it just? How? I'm out here, y'all. Bye. All right, brother. We got your power wires removed. We got the bus removed. This is what you got to think about, all right? This right here is the same type of material as this board is right here, okay? And you'll notice that messengers are pretty bad about since they don't tin their boards. See, tinning your boards helps with the longevity of the board. Having real thin copper like this right here, over time will start to deteriorate. It's just weird. It's just the mixture of moisture in the air, etc. And you'll see that people have already had to repair some that have deteriorated or possibly popped, and that's what all these extra wires are. Kind of wish they would have used Teflon, but you know, you don't have to have Teflon in places where there's not heat. It's just a habit of mine. But this is thin as foil, thin as paper. All right, you had this sitting here like this, soldered to the foil, and this right here is thin as foil. So you got foil soldered to foil. Like I said, this is getting the current first, second, third. By the time it hits all the way out here, both of the wires will solder to this little small square right here. By the time it gets to right here, you've got a voltage drop. I know, I should have took time to actually show that. I think I've got a video or two where I do show that. First person I ever seen show that, God rest his soul, it was Stickman. He was the first person to ever show that to me. He made a little video, a personal video for me. Still got quite a few videos. But anyway, so we got all that took off, got all the flux cleaned off. It was nasty. It was nasty. Got all that cleaned off. I've already started cleaning the amplifier. You can see all the flux is gone. I've already started cleaning the amplifier. Just to give y'all an idea, I know I should have me a little trash can right here and all that. When I get to cleaning, I get to cleaning. Now I'll just sit here and be cleaning, and I'll throw my Q-tip to the back, and when I'm done, I'll suck all up the Q-tips up in the trash can. But I like keeping my leg area down here clean. I just hate rolling my chair over crap, you know. But when you're working on amplifiers, it can get nasty around you. And I don't have a big area to work in right here. You know, it ain't gonna be too much longer. I'm gonna be having my shop, my building that I've been saving for, you know, for quite a few years. And I'll have a lot more room in there to kind of have trash cans beside me and all that type of stuff. But luckily we're out here in the garage on concrete floor. You know, if I was in the house, I wouldn't be able to do all this. So yeah, so we got all that done. Now what I went ahead and did, because I've already ordered a 9-pin Molex connector. Is it 9 pins? Yeah. I've already ordered a 9-pin Molex connector. To keep myself straight, I have drawn a diagram just to keep my mind straight when I'm sitting there putting that back together. As you'll notice, it only uses the side. So this is the ground, this is the B plus coming from the hot bus, this is the preamp switch on, meaning the hot bus is going over to the preamp, meaning if you have a switch, which is right here, and you connect this wire to this wire on the switch, the preamp's going to come on. Alright, here's your TX. This right here is just a B plus. This is actually getting the B plus from when you transmit going to the bias circuit. It's getting that B plus going into the bias circuit. Alright, and that's for the TX light. So it'd be powering a TX light on the remote and on the front at the same time. Alright, here's your switch on for the main relay. Alright, that's your switch on for the main relay. So yeah, all that going through this cable right here will be powering the fans. So when that works out like that, it's probably a little bit less voltage hitting the fan just going through all this cable. But it's not enough to probably cause any issue or any difference whatsoever. And then here's the SSB right here. And the way this SSB is set up, it's getting a ground. So what this is doing up here is it's taking this pin right here and connecting it to this pin right here for the SSB. So that's how that works. Very simple. Very simple. So I like to always do that just to keep my mind straight. You know, if I'm ever struggling a little bit, because, you know, I've already had to unsolder these two wires. That's mainly the only reason I did it, was because I want to know where those need to go back at. But here's the only issue I have. When I remove this, am I going to have enough room to slide the new one in here because of this board? I don't think I'm going to have enough room, and that's very unfortunate. That's probably going to cost me about another hour or 2 hours worth of labor just to get that in there. And about the best way to do this that I'm seeing right here, what's the path of least resistance? Not electrically, but mechanically, physically. I believe it's removing the bolts right here in the back, unsoldering the SOs. Ooh, I was about to say unsoldering the grounds down there, but that ground is hidden. I didn't even notice that yesterday. That ground is hidden up under that relay. You see that? And these wires are not Teflon, so if I put my iron down there to try to heat that up, it's going to melt into those wires. Dang, man. I was hoping I'd be able to just heat these up, unscrew this switch, and just pull this to the back. God dog. You see, these are riveted in here. Man, that sucks, man. That really sucks. So I do not want to have to remove this board back. Can you see what's involved about removing this board? You got 1, 2, 3. Honestly, whenever you don't want to move this board unless you're going to be literally taking it out for good. Man, I'm just looking at how much room. I just don't see me having enough room to squeeze that in there. But we'll figure it out. It's something he wants done, and I can understand why. See? I can understand why. We will figure it out. So I'm going to get back to doing my cleaning. I'm almost done cleaning. We got all these removed. I honestly don't know who wrote this on here. If you see, we got 667 written on it there. We got 711 on there. We got 683. I don't know who done that. I really don't, because that's not how much those capacitance are of each of them. I have done more notes right here for myself. See, I've already wrote down the capacitance. This is what it was said that was on there. But the reason I haven't wrote anything right here yet, which I'm going to go ahead and do it now, is because they're all almost pretty much identically the same, and they're not what's said on here. Pretty much, they're around 550. So I think what we're probably going to be doing is installing some metals on here for the guy. I've got some perfect 500 puff picofarad. I don't usually say puff, because we ain't here puffing on capacitors. So I still am sitting here trying to figure out what the heck was soldered right here. I have no idea. I have absolutely no idea what the heck was soldered right there. So I'm going to suck that up, clean it up. That's what I got these right here for. Old coax shield from your 316 coax works great. If you're needing to suck up stuff to make it smooth, because I'm needing this right here to be smooth, because we're going to be dropping a bus down here. So we need it smooth as perfect. And this is about the perfect width that I need to be dropping this bus down here. It'll work great. It'll work great. I still hadn't completely made up my mind if I'm going to try to come in with 4 10-gauge 8s or 2. We will see. We will see. We will see. We will figure it out. If I did do something like that, this is what I would do. I would drop the first 8 right here, and I would drop the second 8 right there for ground. It gives perfect path to leave resistance equally for both of them, and I would virtually bring them out right here. But I've got some wire that would be perfect for this situation. It's silicone wire, so it's not going to be burning. I'm thinking about possibly using that. It's quite expensive wire. It costs about twice the amount that I normally would spend on something, but I'll feel better about that wire being close to the output transformers, because those can get hot. Those can get hot. Plus, they're real good and flexible. I really love this wire. It's called Super Worm, and if I did that, I could actually come in with 4. I could actually come in with 4 of them, because they're 10 gauge. Boom, 2, 3. Well, this right here will be a little tricky since we got this coax right here. 1, 2, 3. We may could bring the other one right there. We'll see, man. We'll figure it out. Sometimes you just gotta figure out stuff on the fly. Whichever way I do it, it'll be good and it'll work great. So that's all that counts. You just gotta figure out how you feeling that day. I also don't know what was soldered right here. I have no idea. Alright, let me go get to work so we can get this done. We'll be back. Alright, I removed the high-low medium switch, and I thought something looked kind of weird about it, the way it was positioned, and now I see why. The switch is broken. You see how it's missing this piece? And what's kept this working was it just being pressed against it just right. Now this could have been broken while it was sitting in there, but I'm going to take a wild guess that this was removed for some reason at some point. My guess was possibly when this wire was ran. I'm just guessing though. I don't really know why they would need to. Well, yeah, I do too. That had to be soldered right there. And they were able to remove this board right here and get their soldering iron down in there in this direction and solder that right there. So I was removing this to put new resistors on there. Look at them resistors. That one right there has gotten so hot. Now, at this point, what you can do is you can install a variable. Yeah, you can install a variable. Or we can just replace this. Since this is broke. Luckily, I have worked on quite a few of these amplifiers in the past, and I have installed variables on quite a few of them, and removed these, and the customers allowed me to keep these. So what I am going to do now is go search, because it's been a while since I've worked on these, so these are probably kind of tucked away real nice in some of my part bins, but I know I've got a few of these, maybe 2 or 3 of them. Because a lot of guys, you know, like, I don't want that high low, I want to have a variable so I can turn it exactly where I want it. So what we'll do is I'm going to go search. And then once I find one, we're going to remove these resistors. And we are going to put 5-watt resistors on here, which is really what I say should have been on there in the get-go. And if you notice, this 39, let's see, 3 white, big boys race our young girls, but violent generally wins. Yes, white. 39 ohm resistor, that looks the best out of the two. Now, which resistor is hitting what? Just by looking at it, I can't remember. So I think just for the fun of it, I will make a little drawing on there. So, let's go search. Well, it wasn't in here. This is one of my miscellaneous part bins, but you can see this is one that came off of a messenger. I don't know which one, but I hadn't opened this thing up in a few years. One thing I did find is some nice trimmers, 465, 464s. I know there's a couple of customers been needing some of them. Yep, they've gotten so expensive among the years. I can help them out, sell them some good ones that are. One of these days I'm going to go through all these used parts and figure out which parts are good and which ones aren't. Oh, there's another trimmer. I don't normally use these little small ones. I know that came off of a Palomar. I remember I was using that to put screws in. You can also use these and use them as knobs for big trimmers. I watched a ham operator do that. So it's not in here. It's not in here, but this came out of the messenger. A pi attenuator. That's why these two resistors and these two resistors are the same resistors. So the way this works is actually this is a T attenuator. Excuse me. This is a T attenuator. So the signal flows up this way. Signal flows this way. And exits this way. And then here's the shunt. So that's a T attenuator. I'll have to remember to hook that up sometime and see what dB it is, just for the fun of it. So it ain't here. These are all small parts. These are all used parts come out of repairs and stuff. So the only place left I got to go is, oh goodness, I'm going to have to go through box, through box, through box, through box. Whenever I got done with repair, I usually put it in a bag and put it in a box, put it in a bag, put it in a box, and then once it gets kind of full, I'll stuff it up in the storage room. And I've got about maybe 8, 9, 10 boxes strapped full of parts. So like one of these days, I'm gonna do what old stick man used to do, God rest his soul, and he would build what he would call a junkyard amp. And the definition of a junkyard amp is he would use all used parts that he had gotten from repairs and stuff like that the customers didn't want, and he would build himself a junkyard amp, build himself a free amplifier out of used parts just for him to use in the shop. Kind of a little thing he could do every once in a while once he got enough parts added up. And one time he built himself a junkyard 24 pill out of all used pills and unmatched pills and all that, and he ran the heck out of that thing. Alright, I'll be back. Here's the next location. I'm going to have to pull all these boxes down, which I have not gone through in years, and look through them all. Oh my goodness, this ain't going to be fun. I could just throw a variable on there, but I know that guy wants his high, low, medium. Alright, let's get to it. It's nasty in here, I need to clean up. Oh boy, where do I start? You can look up on here and see. Dang, that's a lot of Texas Star boards in that one. I think that's before I moved on my Texas Star stuff to another location. I got used pills in these boxes too, man, that I need to get out and put in my used pill. This is stuff from years ago. Alright, let me get to it. I ain't looking forward to this. I'm going to put on some music. You don't get that lucky. I pulled down the very, very first Very first one. Look what I found. Two of them. So I get to take these two over there and see which one I think's in the best absolute condition, which I think I know which one it is, and install it. But first, put on some 5-watt resistors. I'm kind of curious to see if, because these come on different amps, so the resistors should be the same, but you can see they're not. But we're going to put the resistors on that was on there already. All right, let's get back to work. All righty, I will admit I have spent 2 or 3 hours just on this high-low medium circuit. Here's yours. After removing it good, it just fell apart. All right. I come from my part bin with this one and these. And guess what? None of them were working. So I started cleaning the contacts, and I got this one working. And I went ahead and went to the trouble of installing the 5-watt resistors like I talked about. And I like this one too because all of the traces are still there. What's weird about this is it works. When you spin it left and right a few times, it works fine. You walk away, come back an hour later, it ain't making contact no more. Turn it left and right again, works fine. I'm like, that ain't good enough for me, man. It's kind of crazy. I don't really know why it's doing that, but it ain't these contacts on the top right here that make contact. It's these ones on the bottom. So I don't know. I wasn't exactly using contact cleaner. I was using another type of cleaner. Maybe that's got something to do with it. I'm gonna buy some contact cleaner tomorrow, just to see if I can get this one back to where it's working all the time. So we got this one already done. I got the back of the board right here repaired so it can accept everything. This is high. This is medium. And this is technically low. That's not all the way low. We also have another resistor going shunting the ground. So the low creates a double series shunt L network. What the heck you talking about, gatekeeper? Well, let me explain. You know me, I like to draw diagrams. And so far, this amplifier has caused me to technically draw 3 diagrams already. And this is something I don't know if I've done before yet, of the high-low medium circuit of a messenger. So this may help somebody. We're just going to hold it up right here for a second if somebody wants to do a screenshot and print it out. So you know, I'm a teacher. I like to explain things. So here's how it works. This mechanical switch basically has 2 rows of contacts, 2 separate armatures, if you may, that are turning when you turn, making different connections. So you could call it, this right here is a double pole. Let's see here, hold on. This is a double pole double throw. This is a double pole double throw rotary switch is what it is. Pretty sure that's the proper. Excuse me. This is a double pole 3-pole. I don't know exactly how you categorize rotary switches. I guess you'd call it a 3-throw double pole because this last one here, it touches 3 different. So I don't know what you'd call it. Maybe a double pole, 3-pole, something like that. But that's beside the point. That's beside the point. All right, so when it's on high, I've got it written right here with the color so it's easy to follow. When it's on high, it's flowing through no resistors. A little bit of resistance you see is just from the contacts, which I got written right here. Contact gives you a little bit of impedance, not much. So your RF's input coax to here comes out right here. So when no resistors, it flows through this direction, here, up here, down. Don't worry about this resistor right here. It's just flowing down here to this contact. All right, this lead right here. These right here are the common. Maybe I need to write that down. I'm gonna write that down. This is the common. And this is the common. So we're gonna write it down like this right here. Common. Like that. Okay. So these are the commons. When it's on high, it's touching this one. When it's on... Okay, this is a 3-pole. When it's touching that one, another is touching that one. I should have drew this green one right here over to this one, but I didn't understand that till I got here and saw what this is doing. Touches this, touches this, touches this. So I really should have this green drew right here. But it doesn't matter because all of these are soldered together anyway. There's a trace from here to here. So when you go here, it's connected here. When you go here, it's connected here. You see what I'm saying? All right. So on high, it goes around this way, out. Flows through no resistors. All right. When it's on medium, goes here, flows to here, here, here. Now right here we have a 12 ohm resistor soldered to this, a lead soldered to this. So it's going to flow through this 12 ohm resistor in series. It's going to come here. All right. And yeah, all these right here are soldered to here, but it doesn't matter. It's going to flow this direction. You know what I just noticed? This 82 ohm right here. This is something I didn't even notice before. I was going kind of too quick. This 82 ohm is an L network for both medium and low. So I need to get right here, and I'm gonna write that down there, okay? So the 82 is not doing a whole lot going to ground. It's kind of high up but it's doing a little bit of attenuation, not much. So you got the 12 ohm here, and it flows this way, here, then out. And at the same time, you see how all three of these are connected. This 82 ohm right here is going to ground and solder to ground. So that's an L network. Now what I'm going to do when I get off camera, I'm going to draw this right here again over here for medium. And I'm basically just going to draw going through the 12, then 82 out. Okay. All right. Now here is low. Goes here. Technically it goes here to here. Okay, we'll just follow it. Goes to here. All right, it goes through the 12 ohm. All right, and since this is not touching this, this is touching this. It goes through the 12 ohm, then it goes through the 39 ohm, creating a 51 ohm resistor at 10 watts. So now I got 5 watt resistors on here. These things ain't gonna be turning charred on you and stuff. Goes this direction, then out. And then we also have an 82 ohm resistor shown to the ground, which creates an L attenuator. So we got an L attenuator on low and on medium. Give me 1 second, I'll draw it out. There we go. So we call it an L attenuator, but you know it is technically a voltage divider circuit. I hear you, Boots. Just calm down there, okay? You always try and get in my videos. You always want the limelight. Medium goes to the 12 and comes out. M12 on the series. Then we have that 82 shutting the ground. And this right here is a real good way to attenuate very nicely. It really is a good idea. 82 or 75 is a good resistance to use when you're wanting to do a circuit like this. You can even go up to 100 to 120 ohms. The lower in resistance you go right here, the more attenuation you're going to have, more RFs being shunt to ground. The lower in resistance. The higher in resistance you go right here in series, the more is being shunt. So it's backwards. Just backwards. All right, let's get this thing installed. Oh, and the Molex connector came in. So I'm behind, man. I quoted this fella a price on this, but I had no idea it had all this other wrong with it. I had absolutely no idea. So that price I quoted him, I hate to say, is out the door. It just is what it is. It's just the way these things go. All right, I'm gonna guess I got about another day. I was hoping to be done with this today, but I don't think so. All right. Here's your old connector. And as you can see, it's broke on this side. So these are panel mount. I got a call coming in. It's the old sweet thing. Be right back. Alright, so that sweet thing calling, telling me to get my butt on in the house. It's time for bed. So anyway, we installed the new connector. We didn't solder all your wires, and in the midst of doing that, I'm sorry, man, but I had to draw another diagram just to keep myself straight. I had that diagram, which is basically just a basic block diagram. That's what you call a block diagram of where everything's hooking up to. But I needed a diagram showing me exactly where everything's hooking up to. Exactly. Yeah, it's been a while since I did this many diagrams on an amplifier, but this just helped me to revert back, because I knew I was going to have to unsolder. Where did it go? Here. I knew I was going to have to unsolder all of these wires, and just to try to make everything smoothly. You know, I ain't got the best short-term memory. I wanted to remember, starting from this block right here on down, which one, you know, which solder to. So anyway, before I even carry on to the next step, as you can see, we did get the hot bus down here. I had my sweet thing come out here, and she helped me solder the current block, which is a piece of 8-gauge copper, I believe. Kind of just to help that current even out in the places that you may have. There's really no need for it for how we're doing this, but it's just nice to have it. I need to start doing that on all my builds. But got that down, got everything soldered back to its place. Since we got this hot bus now, I needed to solder another wire over here to the front switch. That's what this is right here. Very short connection. So next, I wanted to make sure that the remote works, and everything in this remote works except the sideband. If we look down in here, we have a broken connection on this board. The SSB is the only thing not making connection. If you see where the orange wire is, that's the wire going to the actual board over here on this side. And the black wire is the ground. There, the trace between the ground and the bottom of that switch has broke. So you know what that means? Oh God. I tell you what, man, it's just one thing after another. To remove this board right here, the switches go out this direction. I think probably the easiest thing for me to do to fix this, instead of trying to remove, unsolder LEDs or unsolder the switches, bring it this way, is just unsolder all of the wires. It's probably going to be another goddamn diagram. God almighty. I'm going to try to see if I can't fix this without doing that. But the problem is down here in the bottom, and these wires are not Teflon wires. And that's fine. These ain't got to be Teflon wires. But if I get down here with my soldering iron, it's going to be tough to keep it away from these wires. So I may just unsolder all these wires. Just draw me a quick diagram, not one that's all neat. Although I guess it would be nice to have a diagram of the remote for people future. But we'll see. I'm gonna try it. But anyway, after I get that fixed, another thing is I went ahead and put a piece of heat shrink on here for you. It's hard figuring out how to do this, make it look good. There was some electrical tape on there. It was sticky and nasty. This is big heat shrink. Only, it leaves a little gap down here, but there's really no way to get smaller heat shrink on this, or unless you did remove all this out. But she's plugged up, man. She's plugged up good and snug, so that's good to go. So let me fix this SSB. Then we'll be on to putting the metals on the transformers and power wires, 2 big grommets, ground wires, and guess what? Putting feet on here, we're done. Here's another thing we went ahead and did. I found out that the fan plug, the female part of the plug on the amp, is still fine. It was, where's it at? It's somewhere around here. I got a lot of junk on here, man. I went ahead and installed a new heavy duty plug on here, put some heat shrink on there for you. And these are plugs that are a lot smaller than the regular plugs that we use. And what's kind of unique about this plug is it uses a pressure point of the bottom of this to create a ground when it's plugged in. I've never seen that before. So there's not an actually electrical lead in here for the ground. I had to solder the actual ground on the actual case of this. I've never seen one of these before. So when you plug it in, you make sure to plug it in all the way, and it's a snug fit that gives you a ground. Really cool. I've never seen that before. So it uses the bottom part right here for the ground. So I've got that fixed. We just need to put 4 legs on there for you so the amp sits upright, and we'll be done. This has been a lot more extensive than I thought it was going to be. We'll be back. All right, brother. Got this cleaned up for you. I got some feet put on there for you. So look, let's get it installed. Alrighty, we are done. Completely done with this Messenger M1200, which is 2 1446s driving 8 2879s. The M1500s are 2 1446s usually, or 455s driving 8 2879s. So I tell you what, man, this I've been up and down this whole amplifier, cleaned it from the up to the back, to the left, to the right. This thing is clean, clean, clean. You will not find any flux anywhere. And if you can find some flux, that's because I just flat out couldn't get to it. There was a lot of cleaning that went into this. Of course, you'll see some flux on the back of that board right there. It's hard to get down in there and clean all that because it tears your cotton swabs up. Alright, so here's all the parts that came out of it. This is the old hot bus. Now we have a lot better power distribution system installed, and I will talk about that here in just a moment. These were the leads that were carrying the DC to each transformer, which is fine with the short length that it is, but you know, if you can always make it thicker, do it, you know. Here's the switch right here, which I was just going to remove to make these 5-watt resistors, and that's when I noticed that it was actually broke on this side right here already, and the only thing that was keeping it in place was it being soldered pretty much. But my guess was there was some issues with it, and that's why it was shorted with this wire. And the funny thing about this wire, it was already almost ready to break right there in the middle, and somebody had heat shrunk that. I don't really know why they did that, but it was heat shrunk where it was soldered. It was on this end right here, and it had broke apart. So anyway, he wanted me to remove and mic in all the trimmers. And these are the 2 electrolytics that we didn't use. And just a couple of capacitors. This right here was the old fan connector. It had lost its thread inside here. So it was just literally coming off. I mean, you could plug it up, pull it out, and it would just completely come unthreaded. So we had to replace that. Here is the old Molex connector. Basically all that happened with this connector is still fine. It just isn't fine for mounting anymore. Because if you see, where is it? Right here on this side, the mounting part of it had broke off. So somebody had siliconed it in there, which was keeping it in place, you know, but it wasn't completely secure. And then here's the old power wires. All right. Now, there's the new power distribution center. I just got left bare wire, but I went ahead and soldered it for you. I didn't solder the ground all the way, just about halfway down. So if you're going to put this in some Anderson connectors or some welding connectors or something like that, you can solder that all the way down. I mainly like to solder them down just so that they stay together when I go to clip them. So basically what we got going on is we've thrown a full copper strip right here with I think it's a 6-gauge bar going down the middle. Okay. We've got 4 10-gauge wires coming in that basically goes to 4 points on this distribution, and each one is very close to this 14-gauge wire going to the output transformers, as you'll see. All right, now this is what we did with the 8-gauge, so it wouldn't get too congested in here. We could have came in with 10-gauge wires, but there really wasn't a need, and I'm going to show you why. This first one comes in right in the middle of these 4 transistors. This one comes in right in the middle of these 4 transistors. Now you see, you've got a copper strip that goes over the whole 8-pin section. Look how close this is to this and this. That's what makes this so adequate. Now, if this did not have the strips here, I wouldn't feel as good about that. I would have probably came in with 4 8-gauge wires, but since we have this copper strip, which is full solid copper, you know, it's thin, but it's solid copper, and it's soldered down at every point for the grounds. So you have that to help with the electron flow from the ground side over to the positive. So that's what you call a real good clean power wire upgrade for sure. Here's the new high-low medium switch, and it's also soldered back in straight, as you can see. The other one's a little crooked. Now this does have a delete switch right here. Up is 2x8, down, the power is reverted just to the 8 transistor section. As you've seen, here's your new feet for your fan. So now the fan can actually get some air when it comes on in the bottom right here. I've already showed this. There's your fan switch. I don't know exactly what size that is, but it may be a 1/8, something like that. But here's all your matched metal clads. 500. They're sitting right there about 530, 528, somewhere around there, picofarad. I'll show it from this angle. So now you got some metals on the output, and them things will last you forever, man. Them things will last you forever. Another thing I went ahead and did is I went ahead and strengthened the ground with solder everywhere I could. In between these sections down here, you'll see, because that was real thin copper. You'll see I did it right here too. You'll see I did it right here under the ground wire right here, under the ground wire right there, right here as well. Basically, I like to do that because after a while this copper will start deteriorating real slow. For one thing, I thickened it up with solder, so it makes it to where it can handle a little bit more current being thickened like that. You know, the best thing to do is try to go and thicken it up everywhere, but you can't get the iron on everything. You'd have to remove resistors. It's just the little bit of stuff adds up together as one, you know. I was thinking about putting a bigger wire right here, but once I examined it, it is pretty thick and adequate for this 2-pill section. And I just left this the way it was. That's perfectly fine. I could have removed that, got some different wire, wrapped it up, but I checked the inductance of this, and it is some high permeability ferrite, so it's perfectly fine for 21446s. Oh boy, so we got you a new knob. You wanted a new knob. I forgot to show the old one. The old one's right here. So we got you a new knob there. Got you some strain release right here. I love using them strain release. Like I said, we installed your new connector right here. Well, this isn't a new connector. This is actually a connector I removed from a Messenger M800. It's one of my personal amps that I've got laying around. It's a part amp. That's where this came from. And we're lucky too, man, because I've actually bought the proper Molex connector. But as you can see, it is not this type. I don't know where in the heck you get this type from. Actually mountable Molex connectors. I have no idea.
The Rockies are on the air.
Hi, Art.
Hi.
Hi, I got a
All
story
right.
from Okinawa.
Okinawa?
Yes.
Alright. So we are all done with this baby. Oh. One more quick scan of the amp. I think I've already showed all the little diagrams I drew that helped me get through this upgrade. I guess you can consider it slash repair. This thing is prestige clean now. I don't even want to know how many Q-tips it took me. I know some people will take these amps and go put them under a high pressure washer and stuff like that. I still ain't gotten real comfortable with doing that yet, getting water. I don't know, it just bothers me thinking about getting water inside these capacitors right here and there's still being moisture in there and you go and key it up and something happens. I don't, you know, maybe let it sit overnight, it'll be fine. Of course, being sealed relays right there, it would be fine. I could, but hot water still ain't gonna get all of the stuff up. It'll get all the dirt, grim, and stuff like that, dust, and all that stuff up, you know. But other than that, it's all right. Let's listen to the fan work. Oh yeah. I need to hook the remote up. I forgot to mention that. We had a repair on this remote as well. The sideband. Man, I swear to God, this dang chair has quit rolling. I gotta sit there and grab the bottom. My big old self, every time I get a new chair, it's like a couple of months, and the front of the chair starts bending forward. I'm like, am I ever going to find me a chair that just stays in its normal position? So anyway, we got the remote fixed. The SSB is now working. So let's go ahead and, just for safety reasons, I'm sorry for the camera work. Let's turn it off. Just for the safety reasons, we're going to go ahead and plug it up, and I put some nice heat shrink on here for you on this. It has some electrical tape and stuff on it before. Now these connectors, these Mullets connectors will just, you know, you just kind of got to snug it in there. And, you know, it's move, you know, that's normal for it to be moving around like that. And when you go to remove it, just kind of wiggle it back and forth to get it pulled out. There really ain't no right or wrong way to really do it, I wouldn't think. Alright, let's get this and just try to see if we can just kind of sit this right here. This thing's not real heavy. For a remote, it's not real heavy. Here, I'm gonna see if I can't just, we'll just cock it back like that right there for now. Messenger always did pretty good making their remotes. There we go. Stay. That's fine. Alright. Alright, all these switches can be off. Let's turn it on. Yeah. There we go. Let's check out the transmit. There we go. There we go. Preamp. We don't have dummy load, but I'm just making sure all the LEDs are working. Nice. Alright. It's on SSB right now. Let's listen to the relay. I'm gonna key and unkey real quick. Alright, that's real quick. SSB. Yep, you can hear the delay in there. These keying circuits, this style delay for SSB is a lot different than what you normally see with the way a lot of us do our sideband delays using 1,000+ microfarad. This is a smaller cap. You see it right there, and it's actually on the base of the transistor. It's actually on the base of the transistor, and it actually works a lot better as a delay. You can use a lot less capacitance. A lot of older amps use this. So, all right, what we're going to do is, I'm so sorry about the camera work, y'all. This chair's not moving when I'm trying to move around. Instead of the chair moving, my butt's moving. I need to, I got a new chair. I just need to bring it out here. So we're going to try this bad boy on low first. All right, I think the most we got out of it before we did all these modifications was, if I remember correctly, it was 900 watts. All right, we got 1,000 in average, 1,000 in PEP. The peak kits on, and guess what? My batteries finally died on me while working on this, so I was forced to go charge my batteries. I was forced. Oh, so look at that. That is on, golly. This thing's increased, I think, quite a little bit. That's 800, almost 800, right there, about 780. What's the RMS? a little bit over 200 watts RMS on low. Now, I'm dead keying about 1 watt, swinging 3 watts average, and we're doing about 16 watts PEP. Okay, so this still could even use more resistance on low. If I had to go back and change it, like if this is my personal lamp, what I would do for low, here, I done forgot. This is one I actually put together, but I found out these contacts in here is kind of dirty, and I'm out of my contact cleaner, so I actually built this to put in here. But I found out that I couldn't be trusted, so I didn't use it. So this 12 and this 39 goes in series. I'd probably upgrade this right here to a 62 ohm. Probably a 62 ohm, or maybe even upgrade this right here to an 82, and then that will. I'd say a 60 to an 82 for low. All right, let's see what it does on medium. Oh, I'm gonna put it back on low. This is your input reflect. Oh, virtually nothing. This is medium. Oh, look at that. Look at that. Doing 1,000. I'm almost done. Doing 1,000 watts on medium. 1,000 whiskeys. And we're on medium, baby. On medium. What's the average power? Oh, man, this thing is stroking, son. Woo! Man, this thing is stroking. I'm about to put in the 2,500 watt slug. Huh? Oh, what was the input? I'm just curious. Oh, man, this input. Master did a good job on this one. I'm going to tell them. They did a dang good job with the tuning on this one. This is on high. Oh, man, this thing is stroking, boy. I swear to God, I swear to y'all, I swear, I did not do anything different with the tuning on this amplifier. Did not do any retuning at all. I might get in the trimmers with metals, power wire upgrade. I did nothing with the tuning. So this increase you're seeing, so y'all think about that if you got a messenger. 2x8. Y'all think about that, okay? This thing is not starving for current whatsoever at this moment. And just to let you know, I got clip-on connectors down here. These are clip-on connectors. So I could still have better connectors on here. There's a little voltage loss from having clip-on connectors like that. It could be better. I could be using welding connectors. All right. Drop my mic. Here is the RMS. And by the way, we're on 14.9. 14.9 on the volt. What's this thing talking? We just get out here and talk, shoot the screw up like this, man. Letting the mop flop go down. Wow. This thing's talking almost 400. Alright. I'm just curious. I'm going to pop this 1,000 out. Put this 2,500 watt slug in. I just want to see, because the way it's hitting that wall, it's got to be doing a little more than 1,000. All right, we're on the 2,500 watt slug. So we're looking at the top scale. Well, that's showing right at 1,000 on the 2,500 watt scale, 2,500 watt slug. You can get a little bit more accurate that way. You know how slugs can show a little difference from slug to slug. But this thing is working nice, man. Working nice. Put just a tad bit more PEP in it, you'll get about 1200 out of it. You're just looking at 8 2290s here, so you know you shouldn't be looking for a whole lot more than that. And plus, you know, you put on a better power supply, get better connectors down here, and you'll get a little bit more out of it. But I'm telling you, if you run it just about where it's at right now, she'll last you. This thing is, oh, let's look at the input reflect on high. Oh man, that input is amazing. And if you'll listen to the fan, you'll hear it slowing down, and you'll see that my lights are dimming. So that'll show you it's pulling that power supply very, very good. So once I start putting that type of load on this supply, we got voltage drop. So at that time, this thing needs to be put on a bigger power supply. But I noticed it wasn't turning off the power supply, so I didn't take time to hook it up to my trusty Tech 9 Technology 240 amp down there. I could have, but you know, I didn't really see that big of a need just for testing and stuff like that. So anyway, you found another too.
Little baby snail.
Let's put that in the camera.
It was crawling up his neck.
Oh,
Hurry up.
it doesn't fail. I don't know where it fell to. My girlfriend just found a baby slug. Look, a slug. You sure it's a snail?
Snail, slug, whatever, they're all the same.
Oh, it's right here, and it landed on my.
Can you see him?
Yeah, let me zoom in on that
He's a
joker.
cute little thing, ain't he?
If you want
I think they're
to call
cute.
that cute.
I mean cute as in little tiny cute.
Man, look, he's leaving a trail behind him. Go ahead and get that joker off my.
That's P.
That's P.
I'm pretty sure it is because he peed after I picked him up. He was dry. I mean, after I got him off of him, he was dry. And then I felt like the more he crawled across my finger, the wetter my finger felt. So I'm guessing it's P, not with his cute.
I'm about to.
Poor thing, I hate to kill him.
Don't kill him. Just go out there and put him somewhere. Ain't no need in killing something if you ain't got to. I know, y'all. I'm a pacifist. I don't like killing things unless I got to. Now, if it's a mouse or a rat, there's a couple things I don't mind putting out of their misery. Spiders, black widows. All right, man. This joker is sewed up, ready to rock and roll. Messenger M1200 2x8. 21446s, driving 8 2290s. Happy to do this work for you, buddy. You might got a messenger you want some work done on like this, give me a shout. Now it's time for me to get my vacuum and clean up all the excess of this work that's been done on this thing. This ain't all of it. I done vacuumed about twice already. This is day number 3 on this amp. That'll give y'all an idea of how much time it'll take on certain amps. But I haven't been, the last couple of days, I haven't been out here all day long because there's a selling part of my business where I'm selling transistors and parts and shipping them. So I got the selling, I got the shipping, and I got the bench work. My girlfriend's about to start working on me full time, which will get me on this bench more, which is where I want to be. This is where I truly want to be. This is where the fun happens. This is where the surgery happens. I want to be where the action is. Don't get me wrong, it's fun selling stuff and all, of course, but I want to work on more of these bad boys for y'all. I know there's a lot of y'all out there wanting me to work on your stuff, and I've been so backed up and I got to turn you down. I hate it. And but I'm still just getting caught up on all this backlog of work. So I'm gonna rock and roll, Mr. Gatekeeper out here in Georgia. God bless every one of y'all. Thanks for tuning in. Thanks for all the comments, all the thumbs up, and all that good stuff. Go out there and be a blessing to somebody, y'all. Do something nice for somebody. You see somebody in need, do something for them. You see somebody out in the grocery store or whatever, ain't got enough money on them, pick up the tab, man. You at the restaurant, the drive-through, and you got a little extra money. You done hit a lottery ticket, or you got paid a little bit extra that week. Pay it forward and tell the person, tell the cashier that you're gonna be paying $20 towards the person behind you, and give them $20 extra. It's those type of good deeds that will come back on your karma in a positive way. But the real way is when you do it, not only trying to do it for good karma, but you just doing it out of the goodness of your heart because it feels good. Old Gatekeeper said that out here around the backwoods of Big GA, baby. We good and going. On to the next project. As my buddy Snoop D-O-double-G used to say, on to the next episode.